Another beautiful question. Two sides of side 1 have a common center. Show that the area of their intersection is greater than 3 by 4. Intersection is overlap. Area here in this area is greater than 3 by 4. Area of the square is 1 into 1. Area of this square is also 1. And they have a common center. But we don't know where exactly it's been positioned. It could be anywhere. And what we are effectively saying is you have a square, you have another square with the same center, and it's pivoted and rotated anyway. But it's exactly on top of this, the common area is the entire area. If it keeps on shifting, the common area will keep on shifting. At some point of time, the common area will become much smaller than the bigger area. But the question is claiming that no matter how much you shift it, minimum 3 by 4 is there in the intersection. Between this green and yellow, what is sitting here in that nice octagon shaped thing is at least 3 by 4, no matter where you shift it. So think about this. You can keep shifting it if it is right on top of the entire overlap. Fine? But if you shift it, maybe you can make this more of a rectangle triangle like this. Shake it like this. Another position. But even then, the area which is common, they're claiming it to be at least 3 by 4. So we need to figure out a way of proving that this is at least 3 by 4. So you can do this in several methods. One is very algebraic, very form-like finding. Other is saying, okay, I need to find the worst case scenario, and I'll plug that in here. Worst case scenario is when it is bang in the middle. So find that, and then you're through. So you can mathematically establish what that area is if it is the worst case scenario. Intuitively, we know if it is bang in the middle, that's where it is worst. And then you can find the answer. But then, if you're a rigorous mathematician, you'll have to prove that bang in the middle is the worst. That's something to still keep in mind. Right? There is yet another method, a different method to approach this one. Right? So we're going to think about that. What are we going to do? We're going to say the common area is this nice octagon. What are we going to do? We're going to draw a beautiful circle. Fine? With the center as a center, and with that circle touching the square. Now, no matter how you rotate the square, this circle is going to sit inside that. That much should be clear. Have a look at the diagram. However you rotate the square, this circle will be inside. Or this circle is contained inside this square, and any other square. So this circle is definitely common. That much we know. We are told that the side of the square is 1. So the radius of this circle is going to be half of that. Because from end to end is 1. We're going only not from end to end, only half of it. The diameter is 1, radius is half. So area of this circle is pi r square. Pi into 1 by 2 whole square, or pi by 4. Now this pi by 4 is definitely common. Definitely sitting in all the squares. Think about this. 3 by 4 is what you need to prove. We know that pi by 4 is definitely common. Pi is more than 3. Or moment we put the circle in between, in that place, you can say for sure that circle is definitely common, sitting inside all those squares. The moment you know that the circle is sitting inside all those squares, we know that pi by 4 is common for all those squares. You know pi by 4 is common, we know it is greater than 3 by 4. Pi is greater than 3. Pi by 4 is greater than 3 by 4.